All right, let's talk about one of the most fundamental, most useful patterns in all of coding: frequency counting. Sounds simple, right? Just counting stuff. But knowing when to use the right tool for the job, well, that can make all the difference in your code's performance. So let's get right into it.
Okay, so picture this. You've got a block of text, any text, and your task is simple. Count up every single character. How many A's? How many B's? How would you do it? You know, this very basic question actually opens the door to a classic and really important trade-off in programming.
So in Java, you've got two main tools in your toolkit for this job. You've got the fixed-sized array and you've got the flexible HashMap. I love this analogy. Think of the array as a specialized socket set. You know, every socket fits one size nut perfectly. It's incredibly fast and efficient for that one job. The HashMap, that's your adjustable wrench. It might be a little clunkier, a little slower, but man, it can handle almost any nut you throw at it. Total flexibility. So here's how we're going to break it all down. First, we'll tackle that core choice, array or map. Then we'll do a deep dive into the lean, mean array. After that, we'll check out the super flexible map. And finally, we'll put them head-to-head on performance and solve a classic coding puzzle.
All right, first up. Look, this whole thing really boils down to one single crucial question you have to ask yourself. Am I going for raw, unadulterated speed inside a very specific set of rules, or do I need the freedom and flexibility to handle absolutely anything? Speed versus flexibility. That's the game. The frequency array, this thing is a champion when you're playing in a sandbox with known rules. It absolutely thrives when you know exactly what you're going to be counting ahead of time. So if you're only dealing with, say, lowercase English letters, that's a fixed set of 26. Or standard ASCII characters, that's 128. When your problem fits neatly inside a box like that, the array is just unbeatable. But what happens when the world is messy, right? What if you don't know what's coming? You might need to count characters from different languages, maybe even emojis. Or hey, maybe you're not even counting characters at all. Maybe you're counting entire words. Well, that's when the HashMap just steps up and shines. It's built for the unpredictable. It gives you the power to count literally anything you can think of. Okay, let's zoom in on that specialized tool. We're talking about the array. Your absolute go-to when you need the best possible performance, but only for a simple, known set of characters.
The magic behind this is just so simple and elegant. All you're doing is creating a dedicated slot or a bucket for every single character you expect to see. So if you know you're only working with lowercase English letters, you just need an array of size 26. That's it. Index 0 is for A, index 1 is for B, all the way up. It's a direct one-to-one mapping, and that's what makes it so incredibly fast.
So how does this work in practice? It's awesome. Just 4 simple steps. First, you create that array. Second, you loop through your text, one character at a time. Now step 3, this is the secret sauce: character arithmetic. By just subtracting the character A from any other lowercase letter, you instantly get its correct index in the array. So C minus A gives you 2. Bam! You jump straight to that slot in memory and bump up the count. It's direct, it's simple, and it is lightning fast. Okay, so that's the lean mean array. Now let's switch gears and pick up our adjustable wrench. Let's talk about the HashMap, the tool you grab when things get complicated and you need to be ready for anything.
This one line of code, this is basically the entire playbook for using a map to count things. And it's so clever. For every character you see, you're essentially telling the computer, hey, go look for this character in my map. Find its current count. If you've never, ever seen it before, no problem, just pretend the count is 0. Now, take that number, add 1 to it, and stick it back in the map. It handles brand new characters and existing ones all in one beautiful, clean operation. And this is where the map just blows the doors off, right? Its power goes way beyond just single characters. You can use this exact same logic to count the frequency of entire words in a book. You can get fancy and use modern Java streams to do it in a more functional style. And if you really need to squeeze out performance, you can even bring in special third-party libraries that give you map-like flexibility with better memory usage. It's just so versatile.
All right, theory time is over. We've seen both tools. Now it's time to put this stuff into practice. Let's see how these two stack up in the real world when we look at performance, and then we'll use our new skills to crush a classic coding interview problem.
So if you look at this chart, you might think, hey, they all look pretty similar. And you're right. In terms of time, they all scale nicely as your text gets bigger. But, and this is a big but, the real difference is in the hidden costs. The array uses a fixed, constant amount of memory. The HashMap's memory grows with every new, unique character it finds. Plus, it has this thing called boxing overhead. It's like for every simple number it needs to store, it has to first carefully wrap it in a special object, like putting it in a box. All that extra wrapping takes time and uses more memory.
So let's just cut to the chase. Here's the bottom line. Arrays are faster for their specific job because they don't have to do any complex calculations to figure out where to store something. They just jump right to a memory address. And they completely avoid that costly boxing we just talked about. So for a known, limited set of things to count, the array will always be the performance king.
Theory's great, but let's get practical. You're in a coding interview, and they hit you with this classic. I'm going to give you 2 strings. Tell me if they're anagrams. Do they have the exact same letters, just maybe mixed up? How would you solve it?
Well, with what we know now about frequency counting, this problem becomes almost trivial. Check this out. We grab the first string, heart. We create our simple frequency array of size 26, and we loop through the word, adding 1 to the count for H, E, A, R, and T. Our array now holds a perfect fingerprint of that first word.
Next, we grab the second string, earth. And here's the clever part. We loop through it, but instead of adding to the counts, we do the opposite. We subtract from the counts in that very same array. We take 1 away for E, 1 for A, 1 for R, and so on.
And now for the grand finale, the elegant check. If and only if those 2 strings were perfect anagrams, then every character we added from the first word should have been perfectly canceled out by the second. So all we have to do is check our array is every single slot back at 0.
Boom! If all the counts are 0, it's a confirmed anagram. How cool is that? We solved a potentially tricky problem super efficiently without any sorting or complicated logic, just by using a simple array as a counter. It's a beautiful solution.
Okay, before we wrap up, let's talk about some pro tips, the stuff that really separates a good coder from a great one. You always have to think about the edge cases. Ask yourself, what kind of characters am I really expecting here? Just simple ASCII or full Unicode with emojis and everything? If you're counting words, did you remember to make everything lowercase first? What if you're counting billions of items? Could your counter overflow? Thinking about these details is what makes your code robust and professional. So there you have it, the lightning-fast, specialized array versus the powerful, do-it-all HashMap. You now know the trade-offs, and you're ready to make the right choice. But this all leads to a much bigger question, doesn't it? We've been assuming you can hold all your counts in memory. But what happens when your data is so massive that you can't? Well, that's a whole other level of problem solving. Thanks for tuning in.